Hello, welcome back to Cracking the Cryptic, and this puzzle has come in from Florian Wertmann. We'll have a look at that in a minute. Today is the 20th, the deadline gone for the a Sudoku hunt this is, which we can now officially admit it was very obvious to anybody who looked at it. It was a Star Wars Sudoku hunt by Peter C. Hayward, very well received. We will be drawing a winner shortly, and Simon will announce that winner. So many thanks to everybody who has written to enter, some very kind words about the hunt. And next month's Patreon content, the reward is going to be easier than any of the last 3 months. Not trivial, but easier. And we do encourage people to have a go. I promise you, it will be easier. We're calling it Quite Approachable Sudoku. Now, and it will feature all the variants from our apps. So you might want to get revising for it by getting one of those apps or more and playing through some of the puzzles to get used to the various rule sets. That is coming up on February the 1st in a while. And also on the links under the video, the Discord server, Sven's Sudoku pad, merchandise, loads going on as always. Thank you if you are still giving us your time anyway. We are very grateful for anybody watching this channel at all. It's amazing to us how many people do that. Now, this puzzle, Florian has called Czarne Kropki. He has a good friend who's Polish, so the title was a no-brainer. I guessed that Czarne Kropki was black dots, but I didn't trust myself. I had to look it up. It is black dots in Polish. And that's because of the unusual layout, which is a couple of arrows and only black dots. So the rules are these. Normal Sudoku rules apply. Digits along an arrow sum to the number in the attached circle. So those two add up to that one, as do those two, and those two add up to that one. A black dot joins two cells with a 1:2 ratio. Now here it comes. All possible black dots are given. Now, most of the puzzles we feature with Kropki dots don't have a negative constraint, but this does. There's nothing about white dots in this puzzle. Don't worry about consecutives. They're irrelevant. But all possible black dots are given. So these two cells, or indeed these two cells, cannot have a 1:2 ratio because there's no black dot between them. And I know from doing negative constraint puzzles that that is going to be important. So get ready for that if you're going to have a go. So, all of that said, let's see what Florian has cooked up for us this time. He's a brilliant puzzle maker, and I expect nothing but the best from him. Let's see how it goes. Let's get cracking. Well, we've got a run of 4 dots here. So that has to be the numbers 1, 2, 4, 8. They've clearly got to be increasing or decreasing in sequence. They've got to have the 1, 8 at the ends and the 2, 4 in the middle, I reckon. Oh, also, that's a sequence of 4. So we can, again, put 1, 8 on the end and 2, 4 in the middle. We don't know whether it goes round 1, 2, 4, 8 or from the bottom 1, 2, 4, 8. But those must be 2, 4. Now, any dot, any cell that is joined to a 1, 2, 4 or 8 must be another in that group. So, I mean, that is 1, 2, 4 or 8. I'm going to mark it. Now, in this box, one of these must be... in fact, we've got 6 dots, 6 cells on black dots. So the others are 5, 7, and 9. One of these is a 3, 6 dot. And the other is the counterpart within the 1, 2, 4, 8 group. I think what might be worth doing is colouring this puzzle. Yeah, let's use the primary colours. Let's make 1, 2, 4, and 8 yellow. 5, 7, and 9 can be blue, and the 3 6s can be red if we ever find any. Right. Yes, okay, this pair is interesting. That's a 2, 4 pair looking at these cells. That means 2 and 4 have both been used. So this can't be 1, 2 because 2's been used. It clearly can't be 2, 4. It can't be 4, 8 because 4's been used. So this must be the other black dot possibilities. That must be 3 and 6, which I said we would make red. So they are red. And that means this cell can't be red because 3 and 6 are looking at it. So those are yellow. These two must be yellow because, again, 3 and 6 are looking at them. Ah, and these two must be yellow because they can't be a 3-6 pair because we've already got that in the box. So, I don't think I know much about the mate. Ah, yes, that is 2 or 4 because it's got a 1-8 looking at it. And that doesn't tell me whether this is an extreme digit or not, I don't think. Okay, this isn't a 3-6 because one of these cells at least has to be a red cell. So you can't have 2 red cells there. So that's yellow. Don't know about this pair. Are those red or are those red? No, don't know about that either. Right, how do we do this? This one could be any of the 1, 2, 4, 8 digits. Where's the other red cell in this box? It's in one of those two. Then where are the red cells in column 6? That's the question. They can't be in this box because they're both up there already. So they're in this box, but they're not next to each other, or 3 would be next to 6 and would get a black dot. So they're separated by a number. Well, we know that these other 3 are the 5, 7, 9, the blue set in the column, because we've had all 4 yellows and both reds. Those are blue in the box as well. That's blue because it's not on a dot. I should have... Oh no, I could only see that once I knew that was red. Right, we've had 1 red, so they can't both be red. These must be red. Those are yellow. This is a colouring exercise. That's so surprising. These are yellow because they see a red cell. That's red to finish the row. That's not red because it would connect with a black dot to that one. So would this with a black dot to that. You can't put red next to red unless there's a black dot between them. So those two are actually both blue, and that's red. And that colours the whole of box 9. And this can't be red because there's a red looking at it. They can't both be red. Now we're going to get up to this arrow soon, I feel. What about those? They can still be yellow, I think. They're much more likely to be a pair of reds, is my feeling. But it's only a feeling, and my feelings are often wrong. Now we've had all 4 yellows there and here. Oh, 3 of these are yellow. One of these is red, isn't it? That's what we said. Yes, there's 2 red, right, these 2 cells have 2 reds looking at them and 4 yellows. They're both blue. That's all the blues done for the column, so those 2 are yellow. These are a yellow and blue pair, and these are a red and blue pair. I don't quite know what to do with that. Right. Remember that this red pair is a 3-6 pair, just as this is. So if you consider 3 and 6 in this box, they can't be there because of this pair, and they can't be there because of this pair. So they must be on a black dot. As soon as you put 1 3 or 6 on a black dot, it's magnetically attracted to the other. The same is sort of true here. Whatever cell, whatever digit this is, must be on one of these black dots because it must appear in one of those 2 cells, so it can't be in any of these. Therefore it goes on a black dot, and again it gets magnetically attracted. So those are either both red or those 2 are both red. And I don't know which way that goes yet. Oh, these 2 cells are the only non-black dot cells left in the column. They're the 2 blue ones. Doesn't really help, but it's interesting. I'm just wondering if I know more than I realise. Okay, here's a thought. One of the, let's call 1 and 8 the extreme digits on a black dot, and 2 and 4 the central ones. So here in box 7, we've got 1 extreme and 1 central. So that must be 1 extreme and 1 central. And this must be one extreme and one central, and so must this. I don't know how to pencil mark that. I'm just going to try and remember it. Just going to fill in 3s and 6s there. It's really here that I need the information. But oh yes, of course, this can't be another central digit, or those would be the two extreme digits, 1 and 8, and that wouldn't work. They wouldn't have a black dot together. So this is an extreme digit, 1 or 8. And this therefore can't be 1 or 8. In fact, that must now be the same as that. This, I can't decide that that's not a 2 or 4, because if that was 4 and that was 8, this would be 2, so there wouldn't be a black dot naturally, so that doesn't help decide that. This can't be a 2 or 4, or it would join on to this. So this is an extreme digit, and therefore this is a central digit. Still not ruling out that this might be yellow. Might be. I think it could go with that. I think there'd have to be a set of the digits 1, 2, 4, 8 if that was the case, but even that's only a feeling. I can't demonstrate it. Oh, and there's probably something easy to do now. Sorry, let me just think a bit. Oh, here's an interesting thought. There's 2 more blues to place in row 3. One of them could be here, but at least one of them is here. No. Oh, I was actually going to say at most one of them is here, and I can't say that. I was thinking that would put a blue digit on the arrow, which, since they're quite high, might be interesting. Right. So there's a red pair on one of those two. There's a red pair there. If these are red, then there's one on each arrow or even in the circle. Oh, if this is a 1-2 pair, that's hard on these arrow cells. The minimum, if this was a 1-2 pair, there's only 2 options. It's 1, 2 or 8, 4. If that's a 1-2 pair, the least these can add up to is 18. So that would be a 9. Oh, and one of them would be a 3-6, and neither of them can be a 3-6. That pair can't be a 3-6 because of that cell. That pair can't be a 3-6 because of that cell. That's brilliant. So this is not a 1-2 pair, and finally we get our first digit in the grid. 8 there, 4 there. This becomes 2. Oh, come on, this is going now, and it stops there. Why did I say that? That's a 4-8 pair. 4 is there, so one of these is a 4. Oh, and over here, 4 goes with 8. I'm sure that's right. 4 goes with 8 because we worked out that this includes an extreme digit. So there's an extreme digit in each of those, and one of them's an 8-4 pair, and one of them is a 2-1 pair. So the 8's in the middle because of that 4. I don't know where the 2-1 go, do I? No, with the 8 in the middle, that doesn't clean that up at all. So that wasn't a useful deduction. Now, what about this? Oh, well, it can't contain 8 now, obviously. Now, if it was a 9, oh my goodness, it's a problem. It's a problem if it's a 9 for the same blinking reason. Are you serious? I think that's right. If this was a 9, the 2 pairs that make up 9 in the box couldn't be 8-1 or 4-5. So there'd have to be 2-7, which is fine, and 3-6, which is not fine because that's our red pair. And we can't put a red pair either looking down that column at that or down that column at that. So this is not a 9. It cannot be a 6 because these would have to be 1, 2, 4 and 5. 4's been used there. This is a 7. And its pairs don't include 4, 3. They are a 1, 6 and a 2, 5. And, oh, 7's blue, isn't it? And I don't know what to do about that. But this is now a 3-9 pair and includes a red cell. So that's not a red pair. Good grief, I thought that was going to be red. So that's yellow. Doesn't have an 8. So it does have a 2. Oh, hang on. It can't have a 4. Because its 4 would either be next to a 4 on this side, which is impossible, or next to an 8, which would need a black dot. So that is a 1-2 pair. That's a 4, which goes with 8 down here. Then we've got a 2-1 pair. This is a 4-8 pair. This is a clever puzzle. 6 in this column has to be here now. It's red, and it therefore can't be in the blue cells. And that might disambiguate some of our 6s. It certainly does. It doesn't do them all. Right, this is obviously a red and a blue. This we don't know. 1-6, wherever it appears, will be yellow and red. 2-5 will be yellow and blue. And I can't rule any of these out yet. That is not a 6 by Sudoku now. 2, 1, 8. Where's the 4 in this? The 4's in one of those two cells. So this is a 1-8 pair. Actually, that's been available for ages, but I hadn't noticed it. Ooh, come on, keep thinking. Maybe the reds. How are we doing on reds? We need a 6 in one of those two cells. I don't know. They're in a pair of black cells over there, but I haven't. Oh, that's a 4-8 pair. Yes, that's good. Right, so we get 1, 2, 4. I've been hitting the wrong button there. Let's undo. Right, 1, and then we go right. 2, 4, 8, 1, 2. So now, yes, that works. This is now 1 or 4. Now, what about the arrow now? 2 and 3 and 6 can't be on it. So it's from 1, 4, 5, 7, 8 and 9. I don't think. Oh, wait. 6, 3 and 2 have to be in the black cells. They're ruled out of all of those places. So these include 2, 3 and 6 with either a 4 or a 1. So 5, 7, 8 and 9 have to be here. I suppose 2 of them could be on the arrow. Well, could they? No, where does 8 go? 8 doesn't go in the black cells because this 8 says not in those 3. And it can't be in this 2 by 2 because there's a 2 as the yellow cell in it. That can't go with an 8. So 8 goes on the arrow, which is brilliant. Because now it must be 8 plus 1 equals 9. That becomes a 4. That fixes 8 and 4, 8 and 4. This can't be a 2 because it's next to a 4. This 1-8 pair I don't know anything about. There's got to be a 4 in here along with the 2 now. This is a 5-7 pair, and this becomes a 1. So that fixes which is the 1-6 and which is the 2-5 on the 7 arrow. Let's do a tiny bit of colouring that I'm now allowed to. 1 blue, 1 red and 1 yellow cell. Oh, that's blue too. 9, 1, 8. This is a 5-7 pair and they're blue. That's a 9 clearly. This can't be 8. We need an 8 in this row. There it is. Right. Now we're on to you. That's a 1-2 pair. That's the 3-6 pair, and that sorts out this at the top, which may have been available some other way. So they're all red. All of these other cells in boxes 1 and 4 are yellow. That one we know is blue. Got one more red to put in. Oh, I don't know. Let's do the numbers. 3, 6, 3, 6, 3, 6, and up here 3 and 6. So we need a 6 here and a 3 somewhere here. Well, it can't be next to the 6. Oh, that deduction's probably been available for a long time. Sorry. Right, 3 there. That's the 6. because that's 3 and that's 6. That is right. So that's all the reds. No. Yes, I can do the last 3 up here now. And that went badly wrong. 9, 3. Let's make it red. There we go. Right, so 5 and 7 are a pair there, and that's a 9. This 2 and 1 are disambiguated. We get a 5 here. We've got 9 and 7 that can go in. Let's colour them blue. This one is blue as well, and up here, I don't know actually yet. That's interesting. We'll find that out in a moment. Let's just keep going with the numbers. We've got 7 there, 5, 9 pair, which sorts out 7 and 5 in box 4. I've written a 2 there, but I think that was a typo from earlier, because it can't be a 2. I hope I haven't used it. Yeah, it was meant to be 5 or 7. Right, I know where 9 goes in this box. It's there. That's 5 or 7. That's 5 or 7, so we know where 9 goes in the column. Yeah, that's all right. That's looking fine. Okay, so how do we do the rest? Never going to disambiguate those on their own. 4, 8, don't know. This 1, 2 pair, they're not trying to touch. Oh yeah, they're done by Sudoku in the rows. Ah, yes, there's a 2, 4 pair there, so that does the 8, 4 pair. I'm happy to bring it down to just blues, but look, 4 can't be next to 2. That is the key. So we get our last 2 yellows, we get our last 2 blues. That's finished the colouring. Let's finish off blues, because I expect they can all be done now. 5, 7, 5, 7, 5, yes. 7 and 9, 5 and 9. There's 1 pair I've just spotted that I haven't done up here. 5 and 7. That's all the blues. Done all the reds. Just got a few yellows to go. That's a 4. That fixes 2 and 4. Now we've got this horrible 1, 8 deadly pattern, but we remember the negative constraint. 8 can't be next to 4 on either side. So those are 8s and those are 1s. And that is Florian's brilliant Chana Kropki puzzle, which I don't know. When have we done a Kropki puzzle that has ended up being a colouring exercise? Or did it not need... I mean, people will probably now say you do it constantly and send me the latest example, but it strikes me as an unusual construction method and very clever, and this was very entertaining. I do like negative constraint puzzles. All the Kropki puzzles that you used to do in championships before Cracking the Cryptic, they always had negative constraints. I got very used to that style, but in many ways it's more interesting when they don't. But this was a very clever puzzle and I really enjoyed it. So thank you as always for watching, and I hope to see you again on the channel soon. Bye for now.